Okay, I'm going to go over how to read a solubility curve. So this is solubility curves explained. All right, so here is our solubility curve. What does this tell you? This tells you how much of a substance you can dissolve in a certain amount of solute at a certain temperature. Okay, so that is the definition of solubility. How much of a solute can be dissolved in a solvent to make a saturated, saturated solution. Okay, so what does that mean? That means if you plot your point on your curve and the point falls directly on the line, on the curve, that's called a saturated solution. If the point falls above the curve, okay, on the line above the line, then that's called a supersaturated solution. All right, because there's more solute than can dissolve at that temperature. But if your point falls below your line, that's called an unsaturated solution. Because what? I can still add more solute at that point, at that temperature. Okay, so let's look at some of these. When 50 grams of potassium chloride. So what you need to do is you need to find your line. And my suggestion is if you're having troubles with these, highlight it. There's my KCl line, potassium chloride. I highlighted it yellow, so I know what line I'm talking about. When 50 grams, so I'm going to find 50 grams because this is your solubility, grams of this salt. These are all salts, by the way, in 100 grams of water. So these are all in 100 grams of water. When 50 grams of potassium chloride is dissolved in 100 grams of water at 50 degrees Celsius, the solution can be classified as what? Okay, so 50 grams at 50 degrees. 50 grams at 50 degrees. So I'm going to go up and I'm going to plot that line, or plot the point, not the line, and then compare it to where my line is. So where is that point in comparison to my line? Notice it is above the line. So right here we said if the point falls above the line, then we're going to classify this solution as supersaturated. All right, let's look at another one. When 30 grams of potassium nitrate. Okay, so again, my suggestion is find your potassium nitrate. Okay, I got KNO3 and I'm going to find my KNO3 line. And here it is, and I'm going to highlight it blue so I know what I'm talking about. When 30 grams of potassium nitrate is dissolved in 100 grams of water at 20 degrees Celsius, the solution can be classified as what? So we got 20 and then 30 grams, and I'm going to go up here and I'm going to plot that point. Now, where is it? It is directly on the line. So anytime it is on the line, what does that mean? If it is on the line, that means it is saturated. All right, here's another one. When 20 grams of potassium chlorate, so KClO3, so let's find that line. We're going to highlight it, KClO3. I'm going to highlight him orange. When 20 grams of potassium chloride is dissolved in 100 grams of water at 80 degrees Celsius, the solution can be classified as what? So we're going to 20 and then across to 80. And again, I'm going to plot my point and compare it to this orange line because that's for my KClO3. Notice it is below the line. So if it falls below the line, it is unsaturated. All right, does that make sense? Okay, which salt shows the most change in solubility as temperature increases? So as my temperature goes up, which line shows the greatest change in solubility. Okay, well, let's look at all these. This one barely changes. Look at the slope on that. We don't have much of a slope, so it can't be that. This one changes at first. Notice it's going backwards. And of all these, which one probably has the greatest slope? I don't even need to calculate slope to see this, but if I'm looking at this one right here, notice that slope, remember that's rise over run, is probably higher than most of these other ones. So we're going to say calcium chloride has the most slope. So this salt was most affected by change as compared to these other ones. Which of these salts decreases in solubility as temperature increases? Well, let's look at that line right there. You see that one? It has a decrease in solubility. So this is the cesium sulfate. Now notice this isn't normal for most salts. Most salts increase in solubility as temperature increases. This one just happens to be different. All right, let's look at another solubility curve. Okay, this one has little arrows pointing to the lines. That's why I like this solubility curve, okay? Let's see, how much potassium chloride can be dissolved in 100 grams of water at 90 degrees? Again, they're all dissolved in 100 grams of water. So I'm going to find my KCl line, and again, I'm going to highlight it. So it's easy to figure out how much potassium chloride can I dissolve at 90. So we're talking about to make a saturated solution. So I'm going to go 90. I'm going to hit this KCl right here, plot my point, and I'm going to come across. All right, notice it's not right at 50, though. It's above that line, not exactly in the middle. So we're going to say approximately 53 degrees Celsius, not 53 degrees Celsius. What am I talking about? 53 grams of potassium chloride can be dissolved at 90 degrees. Okay, what is the solubility of ammonium chloride per 100 grams of water at 50? So again, let's find that line. We got NH4Cl, ammonium chloride. Here we go. And then we're going to look at 50 degrees. And I'm going to come up and I'm going to plot my point. Oh, notice this one isn't much different either. That one's a little bit lower than this one. So we're going to say approximately 51 grams. All right. Notice this one is asking you, at what temperature can 145 grams of potassium iodide, Ki, be dissolved to make a saturated solution? Okay, so let's find our Ki. He's way up here. And we're talking about 145 grams. Well, if this is 140, this must be 150. So right in between, if I plot that point right there and I come down all the way down, and what's my temperature? 20 degrees Celsius. So at 20 degrees Celsius, I can dissolve 145 grams of potassium iodide. Number 13, if 20 grams of sodium chloride is dissolved in 100 grams of water at 50 degrees, how much more sodium chloride will be needed to make the solution saturated? Okay, so let's look at this guy right here. So 20 grams of sodium chloride. So let's find our sodium chloride again. I'm going to highlight it. There it is. All right, so at 50 and 20 grams, 50 and 20 grams. All right, I plotted my point, but right here, notice I need to get up to here. How much do I need to make a saturated solution? So if I plot this point right here, That is unsaturated. And how much more do I need to add to get to the line? So 40 minus 20 would be 20 grams of sodium chloride would be added. There's not one like this on your quiz or your test, by the way. At what temperatures are the solubilities of KNO3 and HCl the same? So let's find HCl. Here's HCl. Okay, he's green now. Oops, I didn't make a very good line. He's green. And at what temperature are him and KNO3 the same? Notice, where do they cross? Right here. So I'm going to come down at what temperature, and that's not quite 40, so approximately 39 degrees Celsius. They cross paths and they are at the same temperature, so they have the same solubility. Let's look at 15. Which compound is least soluble at 50? So if I come up here at 50, what's the first line I cross? This sulfur dioxide. So that compound is least soluble at 50. And I want to point out on this particular one, notice all the different lines that are going backwards on this one. And there's quite a few of them. What's the difference about these? Okay, this is my clue that these are all gases, okay? Because as solubility for a gas, as solubility increases, right? Or as temperature increases, my solubility goes down for a gas. Okay, we learned that earlier. Okay, which salt, so we're talking about a solid salt, not a gas, is most soluble at 60? So I'm going up, most soluble, and the line furthest away is this guy right here. And who is that? Sodium nitrate, NaNO3. Okay, so on the next page, you should be able to answer all these questions about solubility curves now that we've taken our notes. All right, let me know if you have any questions.